On June 2nd and 3rd, 2011, the Center for Design and Geopolitics held its first annual conference in La Jolla at Cal IT2, the California Institute of Telecommunications and Information Technology, on the campus of the University of California at San Diego.
Okay, so our last speaker for today is my friend and everyone's friend, Wright Steenson. I mean, it's a joke, but it really does seem like everywhere I go in different sort of contexts, architecture, new media, design, auto repair, it doesn't really matter who to meet. Whoever I meet also knows Molly. And then it becomes, I think, a sort of running joke with some of Molly's friends that if Molly were to catch, God forbid, were to catch some sort of contagious disease, that the entire design intelligentsia of the Western world would go down with it at this time. Molly, I had the pleasure of speaking on a panel with at South by Southwest this year on the topic of dark urbanism and how the digitalization of the city has the capacity to evolve into something like what Deleuze called as a control society, which was perhaps a bit of a buzzkill at South by Southwest, but this is what you do. Molly is a PhD candidate in the Department of Architecture, the School of Architecture at Princeton. Her dissertation she's writing is about intelligence, interactivity, information, computing and architecture, and really the archaeology of this, the archaeology going back as far as the 50s and 60s of where the idea of interactive architecture, of architecture as information, of information systems as architectures, but also as things that live and operate physically, materially, embedded within our environment. So she spent a lot of time recently with Nicholas Negroponte, who I speak with recently also about the Guardian thing, a lot of work on Cedric Price, Constant, who we just saw with Mackenzie, as well. And so this topic, whereas Lev is sort of beginning to, I think, get around the idea of data as a way in which we can produce a kind of ontological capacity of knowing and seeing the world, and Kelly the way in which that this produces utterly uninnocent forms of claims about that world. In Molly's case, I think it's really about information as a material substrate, as something that produces the world in the way in which both those ontological claims and those political claims can be ascertained, adjudicated, critiqued, and ultimately produced. So with that, my friend Molly.
Great. So if we were just talking about facial recognition and we have no body, then we are talking here today about intelligence in search of a body. And I'm going to be presenting, as I said, rather an archaeology of this and talk about Nicholas Negroponte and his work with the Architecture Machine Group in the 1960s to the early 1980s. So I want to point out something weird about Nicholas Negroponte. If you look at pictures of him online, you find that his hands and his fingers are always gesturing in almost every picture you see, whether it's the old Media Lab picture of his fingers in front of his mouth to talking on stage more recently. As you probably all know, he was born in 1943. You may or may not realize that he was an architect. In fact, did a bachelor's and a master's in architecture at MIT. 5 days later, joined the mechanical engineering department, taking over Steve Kunz's teaching load. He's the father of computer-aided design, and really has never left. He still maintains a status at MIT. And then, as you're probably well aware, he opens the Media Lab in 1985. In an out-of-the-way corner it first inhabited in Building 9 at MIT, the Architecture Machine Group, under Negroponte's direction and that of Leon Goisset, experimented on computing tools for design from 1968 to 1980-1985 when it rolled into the MIT Media Lab. Negroponte described the mission midway through the group's lifespan as follows. The architecture machine has chronologically become a book, a mini-computer, a family of mini-computers, a small curriculum, a computer ethic, another book, and a catch-all for a variety of papers. And with so wide a mission, one wonders what ArcMac, as it was colloquially referred to, did not aim to do. An architecture machine, as Negroponte described it, would turn the design process into a dialogue that would alter the traditional human-machine dynamic. He wrote, quote, "The dialogue would be so intimate, even exclusive, that only mutual persuasion and compromise would bring about ideas unrealizable by either conversant alone. No doubt, in such a symbiosis, it would not be solely the human designer who would decide when the machine was relevant. In order to achieve the design goals in close relationship with the user, the machine would have to incorporate artificial intelligence," Negroponte wrote, quote, "because any design procedure, set of rules, or truism is tenuous if not subversive when used out of context or regardless of context. So intelligence is not a passive quality, but an active one expressed through behavior and interaction and improved over time. The system would learn from its users, and the users themselves would transform in the process. Eventually, we would all live in architecture machines." Negroponte sought to create an actively intelligent machine that could not only model and interact with, but make new worlds. It would be an embodied machine, an embodied intelligence. He wrote, "It is so obvious that our interfaces, that is, our bodies, are intimately related to learning and to how we learn, that one point of departure in artificial intelligence is to concentrate specifically on the interfaces. The appropriate interface for an architecture machine, he thought, would be capable of understanding incomplete inputs, such as verbal messages, gathering information without human intervention, and engaging with symbols, metaphors, and meaning. Input and output devices became a key area of experimentation for ArcMac at the same time as they were a bane for Negroponte, who continually expressed frustration with the clunkiness of input-output mechanisms such as cathode ray tubes and light pens. ArcMac contributed to the device's computer programs that modeled intelligence and then applied the assemblage to spatial and three-dimensional contexts. It's important to note ArcMac's funding origins. ArcMac would be funded by the same entities as MIT's major labs, ARPA and later DARPA, and the Office of Naval Research, and much less the National Science Foundation, who, in Negroponte's own words, "I hated them." I think still does. ArcMac's funding was personality-driven first and foremost, then project-driven from government sources. Why would a laboratory in the Department of Architecture and Planning, led by a man a generation younger, build such close relationships with the most important researchers in the military-industrial sector? To put it simply, the key funders were all mentors and friends of Negroponte's, and to the extent that they are still alive, they still are. In his first, and what you see here is, just to be clear, I just pulled up some of the research interests of both J.C.R. Licklider, who's on the left, and a man named Marvin Denikoff on the right. In his role as the first director of the ARPA Information Processing Techniques Office, Licklider personally funded Negroponte, who then used the funding for ArcMac projects. Licklider's article, Man-Computer Symbiosis, influenced the core ideas Negroponte expressed in the architecture machine, down to the concept of symbiosis that he used in the definition that I gave just a couple of minutes ago. But Negroponte also enjoyed a decades-long relationship with Marvin Denikoff, Director of Information Systems at the Office of Naval Research, who funded not only ArcMac projects, but also many of Marvin Minsky's artificial intelligence group projects, later called the AI Lab. I should mention that Licklider did as well. And there's more to say about AI and architecture and their connections, but I can go into that during discussion. Denikoff pursued an interest in decision support technologies, particularly in university programs that focused on emerging computational practices. He was also an off-hours playwright and photographer, and even joined the Media Lab once he retired from the Office of Naval Research. So the first class that Negroponte and Guasset taught together in the School of Architecture, remember that he spent 2 years from 65 to 67 teaching in the Mechanical Engineering Department in the basic computer-aided design course, was a course called Special Problems in Computer-Aided Design. And this is where the Urban 2 project came to be. It was a joint project/class where the students were working on a workshop basis, and the students would be judged on what they actually contributed to the field. What was important about this was how ArcMac tried to teach architecture to architects. The syllabus says, and I apologize for the quality of the photograph, but a great deal of time would be spent programming in order that the student may be involved with feedback from his own effort as an architect to provide a computer system for architects. At the end of the term, a written report would be assembled and a jury-like presentation held, where the class would present as a whole their step toward a computer-aided urban design package, one developed by architects and for architects. Guasset and Negroponte incorporated their work into the next version of the Urban 2 project, which they called Urban 5. And it was a computer-aided architectural design program that engaged its user in a dialogue as it went along, as they organized 10-foot by 10-foot cubes and then gave them programmatic attributes. So the way it worked, here you see kind of the output of some of the cubes put together. On the right, you see an example of some of the text and dialogue going on. And what you see to the left, the buttons, are what were called modes. So you see a number of different modes, and you could press one of these to get different, to apply different attributes to the cubes that you were organizing. You see graphical modes, contextual. I like the therapeutic modes myself, which, quote, make the designer-machine interface as conversational and personal as possible, permitting the user to articulate himself in the privacy of himself, such as panic, for example. And you can see here the light pen moving around and choosing on the screen from a different set of possibilities. Negroponte, by 1970, said that Urban 5 was a failure. He thought that the programmers were too entrenched in the program structure and that the structure was a bunch of spaghetti. It wasn't general purpose enough, it wasn't robust enough, and its inputs and outputs did not do enough to engage the user. But there's something interesting here, because by celebrating the deficiencies of the program, he justifies the further development of his vision. And he wrote, "Let us build machines that can learn, can grope, and can fumble." He wrote in his conclusion to the book, The Architecture Machine, "Machines equipped with at least those devices that humans employ to design." And in fact, the names of several ArcMac projects, like Hunch, Seek, and Grope, to name a few, embodied the philosophy of their design process. Technologies that guessed at a user's intention by recognizing a sketch, or that used a robot arm to move blocks, or a peripheral that rolled over a map to make sense of a territory. So, for example, Hunch was a sketch recognition program and actively sought to model what humans did imperfectly. Negroponte wrote, it is not looking at the sketch as much as it is looking at you sketching. It is dealing with the verb rather than the noun. It behaves like a person watching you sketch, seeing lines grow, and saying nothing until asked or triggered by a conflict recognized at a higher level of application. So the process here is cybernetic, observing and correcting, but it's something more as well. By recording and rendering these imperfections, Hunch attempted to model human behavior and in the process to try to humanize the computer as a design tool, or so it would seem. This is Grope. Grope is a device that crawls over maps, in this case, Richard Saul Wurman's Atlas. I'll get back to that in a second. And it uses a low-resolution photocell as a seeing mechanism. It determines I see light versus I do not see light. And he wrote about it, Grope knows nothing about images. It deploys a controller that must be furnished with a context and a role as opposed to a goal. Play chess as opposed to win at chess. Grope's role is to seek out interesting things. So I just want to point out what it is rolling over, and this is a reprint from Architecture Canada. It's Urban Atlas, 10 American Cities, which was Richard Saul Wurman and John Passano, a set of maps that looked at, in the ones you see here, for instance, population density, personal income, and land use. And they write that these maps are, quote, organized visually, systematically, and mathematically. Thus, in this form, it can be factored, aggregated, projected in time, and reproduced by automated methods. So what they were trying to do was show things that were better suited toward visual expression, the ground rules that were required for graphics to be easily produced and manipulated, and and something that I thought was very interesting, to feedback and influence the information one gathers and the influence that this has on the form, and then ultimately helping a designer manage creative time. But it's an interesting discussion tool for the method. They even wonder whether these are the most meaningful transpositions that they've made and question that in the text. So it's a learning tool for them as well, and the cybernetic method of feeding back into the design process is present. So again, we return to Grope. As Werman and Passano tried to figure out the feedback loop between information and how it would affect the information a designer gathers, Grope is looking for what's interesting, as they call it, based on a hill climbing method. So it goes a stretch and compares to where it's going to where it goes next. And the early simulations they did before they had their own computing technology showed Grope following a map of Boston, a Werman map of Boston, taking itself along what was ultimately the Boston waterfront, which would seem interesting in several ways. This is Seek. Seek was displayed at the Software Exhibition in 1970 at the Jewish Museum in Boston. A photograph on the exhibition catalog cover depicts a sea of mirrored blocks. And they're in a glass pen, and there's a bed of wood chips with two very handsome gerbils in the foreground looking at the camera. You see overhead a steel and lucite claw guided by a tangle of colored wires and a coiled cord, and it dominates the top half of the photograph. And the caption you see here, it's a little difficult to see, but it says, "Gerbils match wits with computer-built environment." Inside the catalog, the double-page spread introduces the Life in a Computerized Environment section with a rodent's eye perspective showing the gerbil in its environment. The next pages show the 5-foot by 8-foot pen, the tangle of cables connected to a computer, men in ties peering into the city, and the robotic arm looming over the blocks. And the catalog says, "Even in its triviality and simplicity, Seek metaphorically goes beyond the real-world situation where machines cannot respond to the predictable nature of people, gerbils." The description of Seek explains, "Today, machines are poor at handling sudden changes in context and environment. The lack of adaptability is the problem Seek confronts in diminutive." And maybe perhaps the explanation was an apologia, because Seek mostly failed for a simple reason. According to anecdotal accounts, it tended to kill the gerbils. In its later years, ArcMac turned its attention to creating computing environments, turning inside out the concept of a user sitting in front of a computer from about 1976, 77 or so onward. The group developed the spatial data management system that resided in the media room, a physical facility where the user's terminal is literally a room into which one steps. The abstract from SDMS, as it was referred to, quote, addresses the notion of spatiality in databases and describes a computer-based system for the storage and retrieval of pictorial and recorded sound information. At that point in time, it was implemented on a network of 16 computers with a variety of interfaces. Sitting in an Ames chair, outfitted with 2 joysticks, a visitor to the media room would use gestures and voice input to navigate information on 3 screens surrounding the chair. Quote, properly orchestrated, the 2 spatial orders, virtual graphical space and the user's immediate real space in the media room, can converge to become effectively one continuous interactive space, wrote MIT professor and ArcMac member Richard Bolt. The SDMS accessed a store of information called Dataland that provided a convincing impression of interacting with an implicit virtual world of data behind the frame of physical interface. So using the joystick, the user would zoom, this is put that there. Using a joystick, the user would zoom in and out of a graphical user interface, and it's obviously an early version of the desktop computing metaphor. In this one, with voice and gesture commands, the user would say, create a blue square, or put the blue square where? There. And so the system would boom this response, put the blue square where? There. The most evocative spatial project was the Aspen Movie Map, which many of you may be familiar with, which started in 1978. The user would navigate the streets of Aspen with the joystick as a photographic landscape unfolded on screen, not unlike today's Google Street View. Andy Lippman, the project's principal investigator, with graduate students Michael Neimark and Bob Mohl, and undergraduate student Peter Clay, and eventually the rest of ArcMac, attached a tripod to a Jeep and drove through the streets of Aspen, photographing the town. They stored the images on video disc, and as the user zoomed through Aspen on screen, images would load, providing a semblance of three-dimensional travel. In the view of Mohl, who wrote his dissertation on the project, the Aspen Movie Map would, quote, offer a novel form of spatial representation which substitutes for the actual experience. While it couldn't be the real thing, it could potentially get close, he wrote. So why would this matter? DARPA's interest in funding from the project came from an interest in virtual spaces to simulate battle situations. Israeli defense, and it goes back to the hostage situation in Entebbe. In 1976, July 4th, 1976, an Air France flight was hijacked by Palestinian terrorists, and Israel rehearsed the rescue in the Negev desert. They had consulted with firms that had done construction in Africa in the 60s and 70s. They had interviewed all of the freed non-Jewish hostages, and they built a replica airport terminal in the desert. And by simulating and practicing the rescue, they were more successful or largely successful. A substitute for, what's important here is that a substitute for actual experience surely could save lives, but also in the years following the Mansfield Amendment in 1969, which required justification for military funding of research, simulation and safety proved attractive mandates to cover. Negroponte dedicated his first book, The Architecture Machine, quote, to the first machine who can appreciate that can appreciate the gesture. And with it, I think we need to ask about the nature of that gesture. What wasn't an architecture machine, first of all? What started as books, computers, curricula, and ethos became the dominant metaphor for interaction, a world of screens and data and little devices, all adaptive and responsive to our interests. Negroponte certainly envisioned the distant future of architecture machines in that matter. He wrote, "They won't help us design. Instead, we will live in them." His prediction continues. The fantasies of an intelligent and responsive physical environment are too easily limited by the gap between the technology of making things and the science of understanding them. I strongly believe that it is very important to play with these ideas scientifically and explore applications of machine intelligence that totter between being unimaginably oppressive and unbelievably exciting. In this uncanny valley resides the architecture machine. To it, we might apply Ted Nelson's words from the software exhibition. Our bodies are hardware, our behavior software. If anything, the fate of the gerbils, or for that matter, ourselves, highlights our sneaky and tenuous position with the architecture machine, soft in the face of a hard-edged technological fact or a mechanical claw. Will we appreciate its gesture? And thank you.